Solving trigonometric equations for theta angles between 0 and 360 degrees. So basically what we're looking for is the value of the angle theta here that is between 0 to 360, that is within 1 revolution. We want to know that angle and then from 0 to 360 degrees we are going to get 2 of such angles. Now, how do we tackle such equation? So basically what we need to do is to find what I normally call the reference angle from this ratio, this equation. What's the reference angle? So the reference angle, it's nothing but the arc sine, that's the reciprocal, or rather the second function of the trigonometric ratio of whatever is given there, and then 1/2 is 0.5. Now arc sine 0.5, it's nothing but 30 degrees. Now, is it that when I put 30 here, I'm gonna get 1/2? Or how do I know if this is, how then do I find the angle from the reference angle? What you need to recall is the issue of the cast diagram. Now, talking about the cast diagram, we are referring to this diagram whereby we know that this angle here it's 0, this one up there it's 90 degrees, this one here it's 180 degrees, and then this one down here is 270 degrees, and then coming back to this one is 360 degrees. That's 360 degrees. Now, what the cast diagram actually tells us is what angle is positive in which quadrant, what the ratio is positive in which quadrant. Some refer to it as the all students take coffee. Now, what does this mean? This is all. Now, this means that all the trigonometric ratios, that is the sine, the cosine, and the tangent, they are positive in the first quadrant. Now, coming to the second quadrant, it's only sine that is positive, but tan and cosine are negative in the second quadrant. And then in the third quadrant, it's only the tangent that is positive. Cos and sine are both negative. Similarly, in the fourth quadrant, it's only the cosine that is positive. Now, what do I do with the reference angle? We need to check 2 quadrants where the ratio sine is now positive. Checking the sine of the 1/2, it's saying it's positive. So which quadrant is sine positive? And then looking at the quadrant, we can clearly see that sine is positive in this quadrant and this one. Now, what do I do with that information? This is what you are going to do with this information. Now, if it's in the first quadrant, write it as the reference angle. For the second quadrant, you are going to say 180 degrees minus the reference angle. Now in the third quadrant, you are going to just look at this 180 so that you don't forget this one. If you are going back to the, so you have to subtract from 180, and then to the third quadrant it's 180 degrees plus. So this one is 180 degrees plus the reference angle, and then in the fourth quadrant you are going to say 360 degrees plus the reference angle. Now take note of this. You must avoid using the 90 and the 270 degrees because this one actually changes the ratio. For example, sine needs to change to cos. That's something for another day. For this lesson, let's just stick to using 180 degrees and 360. Now let's find the values of theta here. So the first theta is going to be, now let's look at this thing one more time. The ratio we are having is sine, and then the sign of the value of the ratio now here it's positive. There is no sign, which means it's positive. So we are looking for where is the trigonometric ratio sign positive. We want where sign is now positive. In which quadrant it's the sign ratio positive? All are positive here, which means sign is positive here, and then again sign is also positive here. So to get the values of the required angles for us, the first one is going to be the reference angle as it is because it's the first quadrant. Maybe I should write this one as first quadrant. X is equals to 30 degrees, and then the other one is in the second quadrant. Now in the second quadrant, X is actually equals to 180 degrees minus the reference angle, which is 30. This is telling me that now X is equals to 150 degrees. Now those are the two values of theta. So theta is equals to 30 to 150. That's our solution for the first problem. Theta is equals to 30 degrees or 150. Now let's look at the second equation. This one looks a bit trickier than the first one. So the key around solving this equation, it's pretty straightforward. So what you first need to ensure is that the trigonometric ratio is the subject of the formula. Now for this one, we need to first make cosine theta to be, we need to make cosine theta to become the subject of the formula. Now let's see minus 1 here and minus 1 on the other side. So what's going to happen here? We are going to get that now our cosine of theta, let me use x for theta. So that 2 cosine theta is equals to 0 minus 1. That's a negative 1. Then we need to divide this by, divide both sides of the by 2. This one is over 2. This one is over 2. And then what we notice is that the 2's actually cancel out this side, and then you are left with cosine theta to equals to a negative 1 over 1 over 2. Now, let's check. Cosine negative 1 over 2. What is the reference angle for this one here? Now, the reference angle is equals to the arc cos, or the cosine power negative 1, for the inverse cos. It depends on how you call this one. It's actually an arc cos of 1 over 1 over 2. Just in case you're wondering why I'm not putting this negative here, this sign here will always be telling you the quadrant. This is what we use for the choice of our quadrant. For now, finding the reference angle, do not put in the sign there. Now, the reference angle here, arc cos half, it's nothing but 60 degrees. So now let's go and check again. We are looking for what's our ratio here. The ratio is cos, and then what's the sign of the value? The sign here it's negative. Now let's check in which quadrant is the cosine negative. In which quadrants is cosine negative? All of them are positive here. Only sign is positive, which means cos it's negative in the second quadrant, and then all in the third quadrant it's only tan that is positive, which means cos it's also negative here. So what we are going to do, we are just going to take our reference angle, subtract it from 180, add it in 180, then we are going to get the required angles for this. Let's deal with it. So our theta, or rather x, will be equals to the reference angle it's equal to 180 minus the reference angle, and this one is going to give me an x which is actually equals to 180 degrees minus the reference angle. In this case it's 60, so your x is actually equals to 120 degrees. This was the second quadrant. Now in the third quadrant, 1 2 3, x is equals to 180 degrees. That's a plus the reference angle, plus the reference angle. So the x is now equals to 180 degrees, 180 degrees plus the reference angle is 60. So our x is in this case equals to 240 degrees. So basically this is our two angles. Then you can just write it as x is equals to 120 or x is equals to 240 degrees. But then need to be using theta. It's kind of tricky to write in theta for this one. Now hope that was kind of a clear concept. So basically, just to sum it all up, given a trigonometric equation, and then you are required to find the theta that is actually between 0 and 360 degrees. How do we find that angle? First, isolate the trigonometric ratio, that is, make the trigonometric ratio to be the subject of the formula. For example, if you are given something with a cosine of theta, make cos theta to be the subject of the formula. Now once the trigonometric ratio is this, then find the reference angle and then go and check into which quadrants those two angles you are looking for belong. That is by looking at the name of the trigonometric ratio and the sign, and then use the cast diagram to find the two quadrants and then just calculate the reference angle. Thank you for staying tuned.